Now we are starting the k-means cluster. Now clustering is a supervised learning technique, and this is so far we have done the classification which comes under the unsupervised, but now we are going to do an exercise on the under supervised learning, and this technique is known as clustering. Clustering, you understand, it is always you can segregate the entire data set into different groups. So that is what our approach, so that we can decide that which group should be what kind of treatment should be given to different kind of groups, or within that group the individual data sets or data points, right? So k-means clustering is the process that we are going to start. Now before that, again let me clear the output. So once you clear it, we'll start our exercise. So k-means clustering, the name is given as k-means. That means the number k is the number of clusters that we are going to form, and the clustering is the process. So let's run this. Then again importing all the required libraries, that is pandas, numpy, then matplotlib, etc. that we can import. Then we need also the data set. So data set in this case is the clustering itself. So clustering.csv, again in the same manner you can always have a data frame, then pd.readcsv, and then you are going to have df.head. So first top 5 rows will be displayed. So after importing this, so here we are imported the data, and now these are the 5 rows of the data set. And what are the various features in this? Like loan ID, of course this is the ID, then gender, then married or not, dependents, education, self-employed, applicant's income, then co-applicant's income if there is a co-applicant, then loan amount term, then credit history, property area, and loan status. So this is what the various columns or the features that you have, right? So this information is very important and we must always go. This is again the same thing that we have discussed earlier also, that it is known as data exploration. So we must explore our data to the extent it is possible or we need it. Now the next is that now we will be considering only 2 variables from the data, that is the loan amount, because there are so many variables but we don't need all of them. So we need only the loan amount and applicant's income. Now these 2 factors are going to be the decisive factor. So this will make it easy to visualize the steps as well. Let's pick these 2 variables and visualize the data points. So we can, again this is just a mark, so we can run it. Then we are going to write some code so that we can draw a small graph, a scatter plot, and the code for that is x is equal to df, where we are storing these 2 variables values, etc. from the data frame. Then plt scatter x applicant's income and x loan amount, and then color is going to be black, c is equal to black. So whatever color you want you can give that. Then here plt x label annual income, plt y label loan amount, and then show. So when we run this, you can see a graph in black color. Scatter plot has been created, and this tells us that this is the total data set that we have, where annual income is on the x-axis and loan amount is in thousands is in the y-axis, right? So we have got this kind of a scatter plot. Now steps 1 and 2 of k-means were about choosing the number of clusters, that is k, right, and selecting random centroids for each cluster. We will pick 3 clusters and then select from random observation from the data. So we, out of this whole data set, we are going to create 3 clusters so that we can, and then we are going to create the centroid so that we can understand that status of these clusters. So we can again run this. Then step 1 and 2, choose the number of clusters k and select random centroid for each cluster, number of clusters. So again we can run, no effect, k. Now here we are selecting k is equal to 3. That means we have selected that the number of clusters going to be are 3, right, that is k. And now this is the code that we have to write, that is about the, again the scatter plot that you are going to have. Centroid x sample n is equal to k, k is 3 here in this case. You can change the value if you want, that depends on your requirement. plt scatter applicant's income loan amount black, PLT scatter, and then centroid, applicant's income, loan amount, and then that centroid will be in the red color because here we are finding out the centroid. That is why the color of that is going to be red. Then PLT X label, annual income, and Y label is going to be the loan amount in thousands. So once we run it, then you will see that another scatter plot will be created. And now here the centroid is going to be with the red color, as you are seeing here. And other things are almost annual income, then here loan amount in thousands, all these things are going. So that means we have got the scatter plot with a centroid now. Now next is that here the red dots that we have got represent the 3 centroids for each cluster. Note that we have chosen these points randomly, and hence every time you run this code you might get different centroids, right? So because that is always possible, so do not be very particular about it that every time you should get the same result. Most of the time you will see that once you as many times you run, you are going to get different numbers with different results, but that will be approximate. That is not going to be too much of different. So we can run this, no effect on this. Next we will define some conditions to implement the k-means clustering algorithm. Let's first look at the code. So that this of course we have already run. Now next step is assign all the points to the closest cluster centroids. Step 4, recompute centroids of newly formed clusters. Number 5 is the repeat step 3 and 4, because you as many times you want you can go for it. A centroid is a data point, marginally or real, imaginary or real, at the center of a cluster. So again you can run, because normally here it is presented, but maybe it is quite imaginary, you will see. So now the next is, now we are going to write the code for getting the different clusters. We are creating the clusters. So how we are going to do that? This is the diff is equal to 1, j is equal to, these are the 2 variables on the basis of which we are going to create our algorithm. So while diff is not equal to 0, xd is equal to x, I is equal to 1, and then for index 1 row c in centroid. Now these are the for next kind of a loop that we are going to create. So ed is equal to 0, and for index 2, second index, row d in xd dot inter rows, then d1, that is applicant's income, row d applicant's income, this multiplied by 2, that is, then d2 is equal to loan amount, then again loan amount, then again d is equal to np square root d1 plus d2. This of course is a formula that we can refer when we have done the clustering. Ed is equal to append, then xi is equal to ed, then I is equal to I plus 1. So you can increase, you are increasing it after every round. So then again it will go back till those 3 or 4 or whatever number of rounds you want to have for your number of clusters. Now c is equal to 0, index. Now the next process will start. Index row in x in inter rows, minimum distance is row 1, pos position is equal to 1 for I in range k, then again row I plus 1, minimum distribution is equal to row I plus 1, position is equal to I plus 1, and then again, so x cluster is equal to c, centroid news is equal to this, and then you can have the mean of that, loan amount and applicant's amount, and then again if j is equal to 0, diff is equal to 1, j is equal to j plus 1, else again these are the some kind of a if then conditions that we are going to use here for the purpose of creating the different types of clusters. And again else diff centroid new loan amount, centroid loan amount sum, then again plus centroid of the for the new next one, again this, and then we are going to have the sum. So print diff dot sum, centroid is equal to x group by cluster mean loan amount applicant loan. So when you run this like this, after getting a kind of alert, which of course as I said that sometimes these kinds of things you are going to get some results, some figures, and these are something which will be dependent on the number of clusters that you want to create and number of iterations that you want to have in this. I mean the rounds that you are having. So it will create those many numbers like this, right? This is again this is for our understanding as to how many times the total for next loop has gone. Now the next is that these values might vary every time. Again, we run this, therefore here we are stopping this the training when the centroid are not changing. So this will go on, but we can stop it after giving a certain rounds of processes. And then when the centroids are not changing after two iterations, we have initially defined the difference as 1, and inside the while loop we are calculating this difference as the difference between the centroid in the previous iteration and the current iteration. So here we can again run this without any. Now the question may be that how do we know that when to stop? That is the question. But this, of course, once you do it with your experience and with your idea about the this data points itself, you will be able to make out. That is why the domain knowledge is very important. The understanding of the data is very important, that with this type of data, how many iterations would be required, how many rounds should be given. That is always very, very helpful. Then again we run this. So when this difference is 0, we are stopping. That means the criteria is that the difference should be 0. So we can stop it. Let's now visualize, or close to 0. Let's now visualize the clusters we have got. So once again we can simply run it. Now we are going to create the clusters. That is our objective. So color for these 3 types of clusters that we are going to have is blue, green and cyan. These are 3 different colors. For k in range k, again k in range k. So df, your data frame, x cluster is equal to k plus 1. Then plot scatter. A scatter plot is to be created again with df applicants and income and df loan amount, and c color is k, right? So plt scatter plot, again centroids, again we want to have centroid for loan amount, and this is in red color. And this x-axis of we have income, y-axis we have the loan amount in 1000. So once we run it, we are going to have a scatter plot like this, which is as we have specified blue, green and cyan. So the same colors are available. 3 point centroids are available in red color, and again your scatter plot giving the y-axis as loan amount in 1000 and x-axis is income in. So this is how you can create your clusters. This is very, very easy and very useful, because if you have huge amount of data and you don't have any clue, what we have learned in our supervised learning, that we don't have any idea about the labels. So when there is no idea, the only way to get into this to get by creating the clusters. So how to create the cluster? This is the process. So that is why the clustering is very useful. So this is, we can draw our conclusion that here we can clearly visualize 3 clusters that we have seen, and the red dots represent the centroid of each cluster. With this one can easily decide whom the loan should be given. Now you can say, because the criteria is that income and loan amount. So the more the income and lesser is the loan amount, I think it is very easy to decide that whom loan should be given. And the middle point is this, that also is going to helpful, that this is probably our cutoff point. So those income is less than this may not be considered. Those amounts are more than this should not be considered. So some criteria have to be found. But this is a very clear cut example or the results, that on the basis of which we can be, when the loan amount, the loan manager can easily decide. So this completes our K-means clustering. Thank you.